Hey guys, this is Taylor here. Today we are solving the problem number 3637, which is Trionic array part 1. So you are given an integer array nums of length n. An array is trionic if there exist indices 0, p, q, n minus 1 in order such that nums of 0 to p is strictly increasing, nums of p to q is strictly decreasing, nums of q to n minus 1 means last index is strictly increasing again. Return true if nums is trionic, otherwise return false. Okay, so let's see what is given to us. So in our question, we need to find out two indices p and q. Okay, and what is the condition? So like from 0 to p, okay, it should be strictly increasing. From P to Q, it should be strictly decreasing. And from Q to n minus 1 is the last index, this one, it should be again strictly increasing. And strictly increasing means if I am having array like this, 1, 3, 3, 4, so this will not be strictly increasing because these two numbers are same, so it will not be strictly increasing. Okay, so I need to find, so if I observe what I need to do, so 0 is fixed. Okay, this 0 is fixed. N minus 1 is also fixed here. Now I need to find my P or Q will be lying in this part. Okay, so either my P can be this and Q can be this, or Q can be this, or Q can be this, or my P can be this, Q can be this, or I think Q can be this. So this way, we would try to solve this problem using brute force, then we'll optimize this. So brute force will be order of n square solution, and our optimized version will be order of n, and both will be having constant space. So let's try to find out and see how we'll be solving this. So idea behind this problem, so this problem is more on a simulation basis. It's not an algorithmic problem. So if you can observe things, you can solve this problem. And the observation here is, so the clear observation is I need to find P and Q in this range only. So I will, in the brute force, I will try to assign P and Q to every possible numbers, and I will check whether that can be a possible answer or not. If that can be a possible answer, then I think my array can be trionic. If for any p and q, let's say if I assign p here and q here, so I think my array can be trionic. Why? Because 1, 3, 5, it's strictly increasing. Okay, then for p to q, I am having strictly decreasing. Then 4, uh okay, till 2, my q will be here. Okay, my q will be here. So 5 to 2, it's strictly decreasing. Then 2 to 6, it's strictly increasing. So this way, I am able to find p and q such that my properties are satisfying. If none of the p q satisfies the condition, then I can tell that, okay, I can return false. I hope question is clear and how we'll be solving this also clear. So let's try to dry run on one case, then we will try to solve this problem. So here is my test case, and I know one thing for sure, that my P and Q will lie in this range only from 1 to n minus 2. So this is 0th index, this is n minus 1 index, and this is n minus 2 index, and this is first index. So my P and Q must lie in this range only. That is the condition. And what is the second condition? My P would be definitely less than Q. So P would be coming first, then Q would be coming. Okay, these are the two conditions. So I will start my loop from this side. So like P, I will start from 1 to n minus 2. Okay, and I think my Q should be n minus 3. P should be n minus 3 only. So my P and Q both should lie in this range. And if both needed to lie in this range, I think in the worst case, Q should be here. And if Q is here, so in the worst case, P should be here. So I think let me write P equal to n minus 3. So n minus 1, n minus 2, n minus 3. That's why I will be writing loop from 1 to n minus 3, and Q would be going from, I think, 2. Why 2? Because P would be here in the worst case. So for satisfying this condition, P less than Q, my Q should be here, right? That's why I will start from 2. Or ideally, more ideally, I should start from P plus 1. That would be more correct. Okay. And I need to go till, I think my, in the worst case, my n Q could be n minus 2. So let me write down this. So there will be two for loops, and in the brute force approach we'll try. And what we'll check, we'll go from 0 to p to check strictly increasing, strictly increasing. Go from p to q to check strictly decreasing, and go from q to n minus 1 to check strictly increasing again. Okay. So this way, these three things, this is a couple of things for the brute force approach. Let me quickly write down the brute force approach, then we will see how we can optimize this. So let me quickly write down two helper functions first. Increasing I to j for index in range I to j, and I need to check if nums of, so please note one thing, I'm not going till j, I'm going before, I am going till j minus 1. This range function means I am going till j minus 1. So why I'm doing this, let's see, I will tell you. So I am checking like this: index is greater than nums of index plus 1. So I'm doing index plus 1. I'm checking current index and next index. That's why I'm going till j minus 1. So if my this condition is there, I can return definitely a false, otherwise I can return a true. So in any case, if my current index is greater than the next index, then that means it's not strictly increasing. So I will return false, otherwise I will return true. So similarly, I will be writing decreasing function also. I hope I don't need to explain this part again. It's a very simple thing. I to j, I will go if nums of index is less than nums of index plus 1. I think I need to handle one more edge case here, and that edge case is basically if the values are equal to. So that also breach the condition of strictly increasing or decreasing. So if two values are same, we should return a false. Okay. Now brute force. So for p in range, from where to where I can go? I think 1 to n minus 3. So 1 to n 2, I need to go to n minus 3. So actually I need to write n minus 2 for q in range 2 to, or I think p plus 1 to n minus 2 till n minus 2 I should go. So here I will be writing n minus 1, and I need to check if strictly if it is increasing of 0 to p, okay, and is decreasing of p to q, and again is increasing of q to n minus 1. If these conditions are getting satisfied, I can return a true, otherwise my answer will be false. Okay, let's try to quickly run this. Leetcode is taking too much time today, and I don't know where their servers are down or what, but from yesterday itself, Leetcode is taking a lot of time to get the answer from its APIs. Okay, so let me quickly submit this and see whether it's working fine or not. If we see hint for this question as well, so it's telling use brute force approach. So that way, I think okay, brute force is there. Now let's quickly try to optimize this, because I know this is easy problem. Constraints are very less, but still let's try to optimize this. And I feel that this problem is little upper than easy. It's not very easy. So it's based on simulation and all. Okay, so let me bring down the test case. Okay, so here is my test case. Now, just to recall one thing, my P and Q would be lying in this range, and P must be less than Q. So this is the condition, right? And what is the other thing that I should observe? That is my zero nums of 0 would be always less than P, and my Q would be always less than nums of minus 1. Minus 1 means the last index. Okay, and minus 1 I should write better. Okay, so this is my first observation. What is my second observation? In the worst case, my P can be lying here, My p can't cross this, my p can't be here. Okay, this is the condition. My p should be here, and in the worst case, very worst case, my q should be here. Okay, my q can't be here. No, it is not possible. So if this is the case in the worst case, and in this is the case in the worst case, can I write one condition? So if nums of 1, and we have given the constraint like there is always a 3 elements in the array. Okay, so nums of 1 is less than nums of 0 if this is the case, or nums of n minus 2, which is the last second index, is greater than nums of n minus 1 if this is the case. Can I return a false? Can I return a false? Please tell me. I think yes. Why? Because I know one thing, that strictly increasing, then decreasing, then increasing. I need some pattern like this. Let me write down like this. Strictly increasing, then decreasing, then increasing. I need some pattern like this, right? Just to make sure that I am having strictly increasing, can I tell that this element must be greater than this? Yes, I think yes. And to make that strictly increasing in the last again, can I tell that this element should be greater than this? Yes, this is the case. Okay, so if I solve these two cases in the very beginning, my problem is very easy now. Okay, so now next part, what I will be doing, I will be starting from here. Okay, and I will be checking what is the part where I can find p. Okay, what is the best part? So I know one thing, that my p would be lying somewhere. P is here. Why P is here? Because this was increasing. Then suddenly I got a less number. I got a lesser number. So this is my P. So I will try to allocate P. Okay, at its best place. So I will start from here. Let's start from here. Okay, from first index. So I will check. Can this be a P? So I am checking. Okay, this is greater. This can't be a P. Okay, now I am here. Can this be a P? Yes, it can be a P. Okay, so let me assign P to this. Okay, let me assign P. So it's a P. Superb. Now, sorry. So I need to find a Q. Okay, and to find the Q, what is the case? My Q would be again strictly increasing, right? So as soon as I got something like increasing wala thing, then that can be my Q, right? Right, so previously how we found out p? Uh, as soon as we got lesser number, we told that it's p. Now our decreasing pattern started. So decreasing, 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 no issue. But as soon as I got one increasing, then that means I can say that that can be my Q. Okay, let's start from here. Okay, I will start from here. So I will check. Okay, is this okay? I should start from here. I'll tell you. Okay. Now, what I would be doing? I would be checking that whether this two is greater than four. No, it is not. I will check here. Whether this six is greater than two. I have to compare the right index. Whether this six is greater than two. Yes, it is. Yes, it is. That means I found my Q. Okay, let me write Q here. Okay, I found out my Q. Super. Now I once I found out P and Q na, once I found out P and Q, my problem is simple. So I found out valid P and Q. I just need to check one thing, whether this Q from Q to n minus 1 is valid array or not. Q to n minus 1 is valid increasing or not. If Q to n minus 1 is valid increasing, then I can say that my array is balanced. Otherwise, I can't say. I would say that my array is not balanced. Why this is the thing? Because I have checked initially. So this is increasing, this part is increasing, this part is increasing. I have checked, right? And 0 to p is increasing, p to q is decreasing. Till now I am done. Till last part I am done. Okay. So if let's say I'm having very big array like this, I have checked the two parts. So 0 and first index, this is increasing. 0 to p, it's increasing. Yes, it is increasing. P to q, it's decreasing. I have checked. Now q to n minus 1, I need to just validate this part. And n minus 2 to n minus 1 is increasing. I know. So this is the condition that is helping me validate this thing and this thing. Now 0 to p is done, p to q is done. I just need to check q to n minus 1 whether this is valid increasing or not. If this is valid increasing, I can say that my answer is true and the array can be balanced. I can return a true here. Otherwise, I would say that no, it is not possible. And so this is the whole intuition behind this problem and behind this optimization. So you need to solve it brute forcefully first, then you need to make a lot of observations, then you will be definitely able to find out this optimal solution. It's not very tough, but if you are good at simulations, if you try out 2 3 examples yourself, you will definitely able to find out. Okay, so let's start. So let's write pseudocode for this. How we'll be writing this? So what I need to do. So this is my pseudocode first of all. Now what is the next thing I need to do? I need to run a loop for p, or let's say I, equal to 1 to where I can where I can go. I think n minus 1, right? Okay. And initially my p is equal to none and q is also none. Okay. Okay, so what I need to do now, I need to check whether my P is assigned or not. Okay, this is the must condition. So the very first thing we know, right? We need to first assign P, then Q. Why? Because my P is always less than Q. So there is the condition that if P is none, okay, if P is none, if it is null value, then I need to check if it's what? It's decreasing. As soon as I got a decreasing, it's increasing, then no issue, no issue, no issue. Go ahead, go ahead, go ahead. But as soon as it find a decreasing, as soon as it find a decreasing, that means at that index, that can be my I, that can be my P, right? So P I would be assigning, and I would be writing else if. So else if is why I'm writing else if here. So first if P is none, na, then I will be only finding this P. If P is assigned once, then only I will be finding Q. Else if Q is none. Okay, no, Q is null basically. What I need to do? If increasing, right? If as soon as I got something increasing, I can definitely assign a Q there. Simple. It's not a problem. So as soon as so Q is decreasing, 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 no issue. But as soon as I got one increasing, that means that is my Q. That is my Q. Yes, yes, yes. It is. So I will be assigning Q like this. Now there is one edge case that we need to handle here. What is the edge case that we handled there also? If I nums of I equal to nums of I plus 1, that means I can definitely return a false, because this is not yet allowed in the array at any place. That will disturb my increasing and decreasing array. Super. Now what is the next thing I need to do? I need to check for one more case. So what is that case? Else if P and Q. Okay, what does that mean? If P and Q are both assigned, okay, or I can say that Q is if Q is not none, I can do like that also. That's not a problem. If P and Q is both assigned, if P is defined here, Q is defined here, what I need to check? I need to check only one thing, whether this Q to n minus 1 is strictly increasing or not. I need to check only this thing. If this is a valid condition, then I think I would say that my array is, yes, sorted. So sorted means okay, problem is sorted, not array sorted. So I need to check if decreasing, if as soon as I got something decreasing, then I can return a false. But if it's increasing, then no issue, no issue. Go ahead, yes. Now in the last, how would be determining our answer? So if P and Q both are assigned, okay, that means I'm just validating that my P is set, P is on the correct position, Q is on the correct position. Then I can return a true, otherwise I can return a false. Simple. So I hope you got it. I would highly recommend you to please dry run this pseudo code with 2 3 test cases, and just like be into this problem. This problem is not very difficult, but once you observe things, your P and Q lies here, how you would assign P and Q, why you are having this condition, how this condition is very important. This is solving half of my problem. Okay. So I think this problem will become easy. Now let's quickly write actual code for this. So this will not make any problem. Leetcode's contests are very fun these days. Okay. So what is the first condition is if nums of I, nums of 0 basically, I wrote okay one this. If nums of 1 is less than nums of 0, if this is the case, or if nums of minus 2 means the last second element is less than nums of minus 1, that means I can return a false. Okay, I can return a false. Here we have wrote here this. Okay, now superb. Let's define our p and q as none for the I in range where from where I need to start 1 to n minus 2, right? So I would be writing n minus 1 here because this is Python range function. Now what I need to do next thing? So I need to check the very first edge case. If nums of I equal to nums of I plus 1, if this is the case, I can directly return a false. No need to do anything. Super. Else if I can write if P is none. So first I would be assigning P. If it's increasing, I mean sorry, it's decreasing. As soon as I got decreasing, I would be assigning my P. If nums of I plus 1 is less than nums of I, as soon as I got the first decreasing, so as soon as I got the first decreasing here, as soon as I got the first decreasing, I would be assigning my P here, okay? Superb. So I would say that P equal to I. Superb. Now else if Q is none, if nums of I plus 1, as soon as I got first increasing, I would be assigning my Q, right? Superb. Otherwise, else if P and Q, so or more specifically, P is not none and Q is not none. What I need to do? What I need to do? I just need to check whether it's strictly increasing or not. So I am here. This part is sorted. This part is sorted. I need to just check from Q to n minus 1 whether it's strictly increasing or not. If it is not, I will return a false. Otherwise, I can return a true. If nums of I plus 1 is less than nums of I can return a false directly without any hesitation. And outside the loop, I can check basically if P and Q, or more specifically, P is not none and Q is not none, then I can return a true. That means yes, my answer can be valid answer. Otherwise, I can return a false. I hope we got it, how we are solving this problem. I would highly still recommend to go through this problem and try it on your own. Okay, we got some mistake, I think. So we made two silly mistakes. I think this should be out of the for loop. I think I by mistake put it inside. The second thing is basically this should be greater than y because nums of minus 2 means the second largest number can be less than, but it should not be greater than, right? If it is greater than, then only I will return. And the third thing is we should have equal to here because as we are finding that we are checking the edge case here of equal to that should be checked here as well. If as let's say I got 1 1 then 2 then 1 1 it should be like not be present, so I can directly return a false there. I think rest all we are good to go. Let's try to run this and see whether it is working fine or not. Okay, it is working fine. Let's try to submit this and see whether it's working or not. I think it is working. So I hope I'm able to explain you this problem. If I am, please make sure you give a thumbs up and subscribe to our channel. And if you have any feedback, just let me know. And if you have any doubts, please feel free to comment in the comment section. So thank you guys for watching this video. Thank you.